So we are on Chapter 9, Lesson 7, Solving System of Equations Algebraically. Specifically, we're going to be using substitution. This is not an easy one to teach in class, so it is going to definitely be more challenging for you guys. Please watch the video. I really do think it'll help you somewhat. So sometimes one or both equations in a system are written in standard form. You can solve either equation of the system for either x or y and then substitute into the other equation to find the third equation having only one variable. So that was from the textbook. So what they're saying is, this one we're going to start off easy. Hopefully you guys can see this. I feel like it's not as good. All right, hopefully that's a little better. What I'm going to do is, this one happens to just say y equals 2. Our goal basically is to, let's see, where can you guys see it? Our goal is to basically get the ordered pair for where these two intersect. Now you've done it graphing to see where they intersect, whereas now we want to see where they intersect without graphing, and we're using substitution. So we know, remember, x here, y here. So we already know what y is. So that's nice. The second part now is we are going to take this and we're going to substitute it into the first problem. So instead of writing y equals x plus 8, we're going to plug it in. What is y? Well, we know y is 2. So I want you guys to rewrite the problem as 2 equals, again, I'm using this problem here, x plus 8. And then at this point, I can go ahead and solve for x. I'm going to subtract 8, cancel, end up with a negative 6 equals x. Now I can take that and plug it in here. So this is what I would call maybe an easier type problem. The next problem is 3b. I'm going to take a look at, and this is on page 426. So this changes things a little bit. Again, I don't have a nice start where y equals 2. So instead, I'm going to have to do a little bit more work here. You can solve for x or y, but you want to get one of them by themselves on either side of the equation. So I'm going to just go ahead, keep the x here, and then I'm going to add y to both sides. These cancel. I'm left with x equals 1 plus y. So now that I know what x is equal to, it's not the same as this time, because when over here we could automatically put in the answer. We're not quite there yet. So I'm going to go ahead and take this, what x equals, and I'm going to plug it into my first problem here. So I'm going to plug in what is x. So x happens to equal 1 plus y. So instead of writing x minus y, I'm going to write what did x equal in the second problem. So I'm going to rewrite my problem as 1 plus y. That's what I substituted in for x. Then I'm going to rewrite the rest of the problem, minus y equals negative 4. All right, I can drop these parentheses, so I really have 1 plus y minus y equals negative 4. And remember, this is like a 1y and this is a 1y, so 1y minus 1y gives us 0y, so they're gone. Now I'm left with a 1 equals negative 4. When you run across a problem like this, where they actually do not equal each other, this is where we would say no solution. This is the type where they are parallel lines. So when we had graphed them, we ended up graphing them and they had looked like this. They basically have the same slope, and that's why you end up never intersecting. So there is no solution.